Welcome back, everyone. Today we're going to be starting to talk about proofs and how you write a proof. We're going to start off with algebraic equations and being able to justify each step using properties of equality. So go ahead and follow along as we go through these properties of equality. You probably did some of this back in Algebra 1, so it should be a lot of review. So the first one is addition property of equality. So if A is equal to B, let me make this bigger for you. Then A plus C is equal to B plus C. So if two numbers are equal and I add the same thing to them, then those two numbers are equal. Subtraction is very similar. If A is equal to B and I take A minus C equal to B minus C, because I am subtracting the same thing from two equal numbers, the answers will be equivalent. Multiplication property, if A equals B, then AC is equal to BC. Exact same idea, two equivalent numbers. If I multiply by the same thing, they're equal. Division, you guessed it, is exactly the same. If A is equal to B, A over C is equal to B over C. If you divide two equal numbers by the same number, you get an equal expression. Then we have the distributive property. So if we have A parentheses B plus C, that's equal to AB plus AC. So you have to multiply by the first and second term. Substitution property. So if A is equal to B, then A may be replaced by B in any equation. Reflexive property. For any number A is equal to A. So a value always equals itself. That one sounds super obvious, but a lot of times you have to state that. Symmetric property. If A is equal to B, then B equals A. So a lot of times in proofs, you need it to be exactly as the proof statement. So if you look at like number 2, the proof statement is A equals negative 18. So if you end with negative 18 equals A, you have to show that last step by the symmetric property. And then transitive property, if A is equal to B and B is equal to C, then A is equal to C. So this is a lot like the law of syllogism that we did earlier this chapter. So there's some different types of proofs. The first type and the most common type that we're going to use is a 2-column proof. So the left side is going to be all the statements or steps. And the right side is going to be all the reasons. So what types of things can be used as reasons? So you can use properties, like the properties above, definitions, postulates, so like we had in section 2.4, all those postulates, and then theorems. So we're going to go through this together. So given 4x minus 1 equals 27, prove x is equal to 7. So basically they're showing the steps. So if you look from line 1 to line 2, what is different? Well, they added 1 to both sides. So that would be the addition property. Then if you look at step 3, going from line 2 to line 3, they divided. So that's the division property. Okay, so moving on to the next set. So number 2, first statement's always given. Now we have to figure out what did they do from step 1 to step 2. Well, they subtracted 2. So that's the subtraction property. What did they do to go from 2 to 3? They multiplied by -6, so multiplication property. Okay, moving on to number 3. First one is given. They just took it directly from the given. Then you look at what did they do to go from step 1 to step 2. They distributed, so distributed property. How did they go from step 2 to step 3? They got rid of the 27 by subtracting. So that's subtraction property. And then what did they do? So they divided by -18. So that's division property. Okay, continuing on to number 4. They took the given, then we look at what did they do. So they subtracted 6x on both sides, that's subtraction. How'd they get to step 3? Well, they added that 17 to both sides, so addition. Step 4, they divided by 2, so division. And step 5, so they flipped the order. So if you go back and look at your properties, if A equals B, then B equals A, that is the symmetric property. So like I was talking about earlier, you have to get it to match exactly. So it has to be x equals 12, not 12 equals x. Okay, last one in this section. So the given, then it looks like they use the distributed property in line 2. To go from 2 to 3, it looks like they just combined the -7x and the 4x. So we would just call that simplifying. They didn't move anything to a different side, they just simplified. Then from there, they subtracted 12x on both sides, so that's subtraction. Then they added 14 to both sides, so that's addition. And then they divided by -15. So that is number 5. So continuing on. Okay, let me zoom out for a second. All right, this should work. So algebraic proofs. So I'm going to do a couple of these with you, and then I'm going to have you try some on your own. So this is where we're going to start from scratch. So you always start with the given. So 3x plus 1 equals -14. And that's given. So then I have to decide, well, what could I do? So I would subtract 1 first. So if I do that, I get 3x equals -15. That's by subtraction. Then I would divide by 3. So x would be -5. That's division, and we don't need that last line. We're done. Okay, I'm going to let you try 2 and 3 on your own, but we'll do 4 together. I'm going to write out 5y minus 1 over 2 equals 7, given. Then I'd multiply by 2. So I have 5y minus 1 equals 14. That's by multiplication. Then I'd add 1, so 5y equals 15. Addition. Then I would divide by 5, so y is equal to 3. Division. Awesome, so that is doing the proofs by hand. Try to do 2 and 3 on your own and check your answers on Classroom. Last part of this section is just matching up the properties with different scenarios. So again, I'll do some of these with you, and then I want you to try to do the rest on your own and check your answers on Classroom. So if k equals 3, then 3 is equal to k. So that's the if a equals b, then b equals a, which is the symmetric property. So that's H. And by the way, the properties could be used more than once. If 2x equals 14, then x equals 7. So you divide it by 2, so that would be division, or D. 4 equals 4, so that's like a equals a, and that is reflexive, or G. If negative 5x minus 1 equals negative 11, then negative 5x equals negative 10. They added 1 to both sides, so that's addition, or A. If 10a equals 2b and 2b equals c, then 10a equals c. So that's the if a equals b and b equals c, then a equals c. So that's the transitive I. Negative 7 times x minus 4 equals negative 7x plus 24. That's distributive, E. If 6y equals 24, then 6y minus 3 equals 24 minus 3. So they substituted 24 for 6y, so that's substitution, F. If 10x plus w equals 41 and w equals 1, then 10x plus 1 is equal to 41. So that one is also going to be substitution because they're replacing the w with 1. There we go. So I'm going to let you try the second half on your own, and then you can check your work on Classroom. So good job, guys. That's it for section 2.5. See you next time.